In this video, we're going to look at random processes and relative frequency. Part 1. A fair coin is tossed repeatedly. The graph represents the relative frequency of heads that occur, which is the number of heads divided by the total number of tosses, versus the number of times the coin was tossed for the first 10 tosses. The table shows these categories, and in addition, the total number of heads after each number of tosses. Use this information to answer the questions below. So before we look at the questions, let's just take a look at this graph in this table. So notice the horizontal axis has the number of coin flips, and the vertical axis has the relative frequency of heads. And the relative frequency ranges from 0 to 1, because since it's a relative frequency, this is the number of heads divided by the total number of coin flips. So since you can't have more heads than coin flips, the largest you can get is 1, and you cannot get a negative number. So just looking at this, I can see that the first 3 tosses were all tails because we didn't get any heads. Then we get a head, and this is 0.25, so 1 out of 4. Okay, and it looks like it's increasing a little bit, and then it's going up and down. Okay. And here, we're calling this the short-term relative frequency because it's just for the first 10 tosses. Okay. So we have the number of tosses, the number of heads. So like I said, the first 3 tosses were all tails. Then we got a head. Then we got another head, another head. Looks like we got a tail here, another head, and then these 2 were tails. And the relative frequency is just the number of heads divided by the number of tosses. So let's look at the first questions. What is the minimum relative frequency of the number of heads for the first 10 tosses? So I am going to scan the relative frequency column, which is right here, and we want the minimum relative frequency. And notice the smallest number in this list is 0. So we'll call it the min. We'll use RF for short because it takes too long to write it. Is 0. Okay. Next question. What is the maximum relative frequency of the number of heads for the first 10 tosses? So now we're going to look for the maximum number here. So it looks like for tosses 6 and 8, we had 0.5, or half the tosses at those points were heads. So notice here we have 3 heads out of 6. Here we have 4 heads out of 8, which gives us 0.5. And you're probably familiar with coin tossing. We should expect, on average, that tossing a coin 50% of the time, or sometimes we say 50-50, which is really an odd statement, which we'll learn about later, we will get a head and the other times we'll get a tails. And that's what it means to be a fair coin. But notice, so max RF is 0.5. Okay. Here, we don't have 50% all the time when we're actually performing this experiment of physically flipping a coin. A couple of times here we hit 50%, but the other times we did not. Okay. Now let's look at the last question. What is the difference between the minimum relative frequency and the maximum relative frequency of the number of heads for the first 10 tosses? So our last 2 values, but we want to write our answer as a percent. So let's go ahead. The maximum relative frequency is larger, so 0.5 is the same as 50%. I'm going to find the difference, so we subtract minus 0%. So the difference between the smallest relative frequency and the largest relative frequency is 50%. Okay? And this is going to connect to some ideas later. This is actually a pretty large disparity between the values. Okay. Now here we have a graph and a table, and this is from the same random process of flipping a coin. However, look at the number of coin flips here. So you can read through this, but I'm just going to go through the graph. So 100, 200, 300, etc. up to 1,000. So at first, we might say definitely up the first 100 flips and here a little bit. We would say that these values are unpredictable, okay? But as we continue on with the number of flips, we have what we call long-term stability. meaning that the more we flip the coins, the more that the ratio of the relative frequency gets closer or stays around some value. And that value is actually the theoretical probability. So like we said before, flipping a coin and getting heads, it's 50% or 0.5, and this graph is actually getting closer to 0.5. It can go a little bit further away and then get a little bit closer later, but notice it's hovering around 50%. Okay? And that's a big idea in probability that you should think about when you're finding theoretical probabilities. Is what we're talking about is what we'd expect in the long run. And at first, in a single case or even in a few 100 or 10 cases, we can expect the outcomes to be unpredictable. Okay. So now here's a chart. So this went to 1,000, but we're going to go out even further in this chart. This is 9,991 tosses to 10,000 tosses. And again, the number of heads that we get, the cumulative number of heads, and the corresponding relative frequency, dividing the number of heads by the number of tosses. So let's answer some questions about this. So what is the minimum relative frequency of the number of heads for the tosses between 9,991 and 10,000? So our chart, here's relative frequency. Okay. Now these will take a little more careful looking. They're all 0.49. Then we have 6.3, 6.4. Here we have some 6.2s, so that's going to be our minimum. So min RF is 0.4962. Now the next question asks for the maximum relative frequency of the number of heads. So our largest number, I think here we had a 6.4, so that's the largest number. So maximum relative frequency is 0.49, whoops, that is not a 9, 4964. And now, just like the last problem, we're asked for the difference between the minimum and maximum relative frequency, and to write our answer as a percent. Okay. So what we're going to see, remember when we only had 10 tosses, the difference between the minimum and maximum relative frequency was 50%. Our smallest was 0%, our largest was 50%. Here, I'm going to move the decimal and write these as percents. We have 49.64% minus 49.62%. And subtracting this, notice we'd get 0.02. And that's already a percent. It's tempting to move the decimal, but we had them as percents already. So this is 0.02% difference. Okay? And again, that's showing our long-term stability as we do more tosses. Let's look at the next question. Since the coin is fair, on average, approximately half of the tosses should be heads. So when the coin is tossed 10,000 times, approximately 5,000 of the tosses should be heads. What is the actual number of heads for 10,000 tosses as given by the chart? Okay, so number of tosses, here's 10,000, and the actual number of heads is 4,962. Let's look at the next question. What is the difference between the number of heads we should expect on average, so 5,000, and the actual number of heads for 10,000 tosses? So we should expect 5,000 if half of them were heads. We have 4,962, and that difference, that's 38 heads less than we'd expect if we got exactly half of the tosses to be heads. Okay? So the point of this is 38 heads that's kind of a big difference. But big is all relative. That's why we call it relative frequency. Since we have 10,000 tosses, to be 38 heads off in the negative direction compared to 500 isn't really that much. Okay? And this difference will actually increase the more tosses you take. However, this ratio will, for the most part, get closer to 0.5. Okay, something to notice here, it was actually, when it's 4964, it's actually closer to 0.5 than it is here. It moved a little bit further away from 0.5. And that can happen. Okay, it's not going to go exactly to 0.5 and just stay there. But the idea with statistics and probability, which can be a tricky idea to grasp in math, is that it's on average somewhat close. Okay. And then finally, we're asked, what is the difference between the percent we expect to be heads on average, 50%, and the relative frequency as a percent? Well, we have 50%, and then here, since it's 10,000, actually we have it right here, there's a relative frequency, minus 49.62%. Okay, so that difference is 0.38%. Okay, so again, 38 heads may seem like that amount of heads is very off from what it should be, but percentage-wise or relative frequency-wise, it's 0.38%, which is a small number.